Welcome, students. We're going to look at lesson 15 in unit 5 of your workbooks. So if you haven't turned there or opened those workbooks, go ahead and do that. The first thing I want to show you, though, is a video that's going to show you the relationship between finding the volume of cones, comparing that to finding the volume of cylinders. Because we already know how to find the volume of a cylinder. Let me get my pen working here. The volume of a cylinder is, that's supposed to be an I, is the area of the base, which is pi r squared, times the height. So now let's look at that video to show us how the area of a cone with the same height and the same radius are related. So let's see if we can get this to play. All right, here we go. There's no sound to it, so I'm going to show you. What they're doing there is they're showing you the cone is the same height as the cylinder, and there they're showing you that the diameter of the cone and the diameter of the cylinder are the same. So they're going to fill up the cone with water. So there's the volume of the cone. He's filling it to the very top and dumping it into the cylinder. And boy, that didn't even come up halfway. So let's look at the next one. He's filling it up again, very tippy top, filling it all the way, dumping it in, and we're still not there. So that's the second cone he has filled up. I think it's a he. And then there's number 3 and dumping it in. So basically what they showed you is to fill up the cylinder with the same exact diameter and the same exact height as that cone, it takes 3 volumes of the cone. So if you have the volume of a cone, you multiply it by 3, you're going to have the volume of that cylinder. Or the other way around, if you have the volume of the cylinder, you can divide by 3 or multiply by 1/3 and get the volume of the cone. Now do keep in mind they have to be the same exact height and they have to have the same exact diameter. So let's go ahead and take a look at our lesson now. And the first part, I'm in the second part of your lesson called From Cylinders to Cones. And it says that we have a cone and a cylinder that have, again, the same height and their bases are congruent. That means they are the same radius, same diameter. And they're asking us if the volume of the cylinder, so here's the volume of the cylinder, is 90 cubic centimeters, what would be the volume of the cone? Well, we saw that the volume of the cylinder was 3 times the amount as the volume of the cone, which means if we took, let's see, the volume of the cylinder is 3 is 90. So that means this cone is 1/3 the size of the cylinder. So that means I can take 1/3 and multiply it times 90 and find the volume of this cone. So the cylinder is 90, this is 1/3 the size, so 1/3 of 90 would be 30 cubic centimeters. Okay, the next one says the cone is 120 centimeters squared, so this is 120 centimeters, but we know that we can fit 3 of these inside the cylinder. So 120 times 3 will equal 360 cubic centimeters. All right, so now they're saying if the volume of the cylinder is this, which we know is true, it's the area of the base, which is pi times radius squared times the height, what would be the volume of a cone? Well, we did that up here. We know the cone is 1/3 of the volume of a cylinder. So the volume of a cone would be 1/3 times the pi times the radius times the height. So this is the volume of a cone, and I want you to star it, circle it, make note of it, put it in your brain because that's what you're going to need to use for the rest of this lesson and for some lessons coming up. So in part 3, we're going to talk about calculating that cone. They gave us a cylinder and a cone, and again, they have the same height and the same base area. They want to know what is the volume of each figure. Well, the cylinder has a diameter of 5, so I know the radius is half of that, so the radius is 5. And they said that the cone has the same base area, so this radius is 5. They also said that they have the same height. They only gave us the height of the cylinder, but if they're the same, I know that the height of the cone is also 4. So let's start with the area of the cylinder. I'm sorry, I don't know why I'm saying area. It's the volume of a cylinder. The volume of the cylinder is the area of the base, which is pi times the radius squared times the height. So let's fill in what we know. We know that pi, and they don't want us to use, so we're expressing our answers in terms of pi, the pi symbol. So pi times the radius squared. So the radius is 5. 5 squared is 5 times itself, which is 25, times the height, and we have the height of 4. So I have pi times 25 times 4, which is 100. So I have 100 pi. And that is the area of the cylinder. I'm sorry, the volume of the cylinder. So now I need to know the volume of the cone. And we already said up here that the volume of the cone is 1/3 the volume of the cylinder. So we know they have the same base and the same height. So if we find the volume of the cylinder, we know we can take that volume and simply multiply it by 1/3, and that's how we're going to find the volume of the cone. So 1/3 times 100 is 100/3 pi, and that's all you need to do. Number 2 says we have a cone, and they want to know what is the area of the base, and express your answers in terms of pi. Well, the area of the base is pi r squared. So r is the radius, and that's 6. So pi times 6 squared is going to be 36 pi. That's the area of the base. Then they're asking you, what is the volume of the cone? Well, we know the volume of the cone is 1/3 times pi times radius squared times height. Well, I already have this number. This number here is the area of the base, which is this. And so we're going to replace this with the 36 pi. So I've got 1/3 times 36 pi times the height, which I know is 8, which is in the figure right here. So I can go ahead and cross cancel. This is like 36 over 1. 3 goes into itself once. 3 goes into 36. 12 times, not 9 times, 12 times. And so now I have 1 over 1, which is 1. Find a place to write this. 12 times 8, which is 96 over 1 times pi. Now they're asking you, a cone-shaped popcorn cup has a radius of 5 and a height of 9. How many cubic centimeters of popcorn can fit in the cup? And they want you to use 3.14. So instead of pi, they want us to substitute 3.14 and give them a numerical answer, which is a number instead of this symbol answer. So again, the volume of a cone is 1/3 times pi times my radius squared times my height. And let's see what we have. 1/3 is a straight shot. Pi, they want us to use 3.14. Radius, they tell us, is 5 centimeters. So I have 5 squared. And the height, they tell us, is 9. So let's rewrite this again. 1/3 times 3.14 times 25 times 9. And again, this is 1/3, and this is like 9/1. And I'm choosing this number because I'm choosing 9 to put over 1 because it goes with the 3. If this were 1/5, I might put 25/1. 3 goes into itself once. 3 goes into 9 3 times. So I have 1/1, so that cancels out. I have 3.14 times 25 times 3. I can do 25 times 3 is 75. This is where I get my calculator out. And when I get my calculator out, I'm going to get 235.5. And that is cubic centimeters. So that popcorn cone can hold 235.5 cubic centimeters of popcorn. So let's take a look at, I believe, is our summary, because that's a pretty short lesson. So this one says, if a cone and a cylinder have the same base and the same height, the volume of the cone is 1/3 the volume of the cylinder. But again, it has to have the same base and the same height. That's the important part. If the height of the cone is 9 and the height of the cylinder is 7, this formula is not going to work. And if you can find one, they're the same base and the same height. If you find one, you can always find the volume of the other by using this 1/3 or multiplying by 3. If you don't have that, you can just know that the volume to find the volume of cone is 1/3 times pi times the radius squared times the height. And that's our lesson for today. I hope you have a great afternoon or morning, depending on when you're watching this. I'll see you in class next time.